The goal of our project was to design a GAN network that would colorize grayscale videos. We thought about a GAN because we're interested mostly in plausible colorization rather than exact colorization. So GANs are already being used to colorize images, but the issue with video colorization is that we want a consistent colorization between frames. We want, for example, that a balloon, if it's colorized in blue, stays blue in all the frames.
And going on to our model, our discriminator would take two consecutive colored images and trying to learn whether they are indeed coming from a colorized video or if one of them is fake. Essentially, this is a conditional generative adversarial network where we condition on the previous colored frame. On the other hand, our generator model would take in a grayscale image at time t and the previous colored frame and try to generate a colored version of the grayscale image that can fool the discriminator. In terms of architecture, for our generator, we used a modified version of a UNet, except that we replaced all max pooling with strided convolutions and we introduced batch normalization after each layer as recommended by the DC-GAN paper.
On the figure, you can see some results. The first two lines present the ground truth of the video. The first one is a grayscale video and the second one is the color video. The third line presents our baseline where we used image colorization frame per frame, and we can see that as expected we have some consistency issue. For example, the sweater is gray on one frame and becomes red on the other one. The fourth line presents the color transfer results using our GAN. Basically, we use the ground truth at time t to colorize the next image at time t+1, and we can see that the GAN does a pretty good job. However, when we try to use it as a hand-to-hand pipeline, using the GAN to propagate the colors along the frames, we can see that as soon as it makes a mistake, this mistake is amplified and the colors become bad at the end. The last lines is our attempt at solving this issue. Basically, instead of training on consecutive frames, we train on more time-space frame so that the GAN will learn some movement and to track objects. And we can see that it kind of does. For example, the end of this toggle is still colorized in pink even though it moved. Finally, we tried another approach, is that to avoid this exponential error propagation, we tried to condition also on the first frame which had good colors, but it didn't went well and the GAN didn't learn to identify region in the initial frame to propagate it.
As part of our future work, we also considered using recurrent convolutional neural net that can directly work on sequences of images.